Okay, so hi everyone. Welcome to yet another session with Mumbai Java user group. Today's session, we are specifically going to talk about JSR381. Now, what is JSR381? It's basically, a Java-based machine learning API for detecting objects and images. It's more around visual recognition. And to talk more about it, we have our awesome speakers. We have Frank Greco from NYSIG, and he's a Java champion, and he's also spec lead for JSR381. Hey Frank. We also have Zoran, and Zoran is also the spec lead for 381. He's also Java champion. And uh, my connection with Zoran and Frank goes a long way. When I was in New York, and I met Frank, and he conducts, in the NY6 sessions. And Zoran and I got opportunity to connect in JCrete session in 2017. So welcome on board, and thanks for giving this time for the session. And we also have Nishant Raut, who is very active committee member for Mumbai Java User Group. And welcome, Nishant. And thanks everyone for joining. So in terms of logistics, we have quite a lot of crowd. So, as logistics wise, what we'll do is we'll keep the question answer session for the end. So you can keep on posting your question on the chat window. I will keep on monitoring, and I will be the coordinator to ask them. And at the end, we will also have Q&A sessions. So with that, all over to you, Frank.
There. Okay, thank you. Thank you, Jitin. Let me share my screen. Okay, can you see my screen?
Yep.
Perfect, perfect. So good evening, everybody, and or good afternoon. Thank you for inviting us to talk about JSR 381. It's certainly been quite exciting for Zoran and myself. So I wanted to give you a little quick outline of our talk. So what I'll do is I'll just take a quick back step into machine learning and why machine learning. I think you've certainly all heard of machine learning, the importance of machine learning to Java, and not just to Java, but to the world. And then Zoran will dive into more of the architecture and the design of JSR 381 to show you how we designed it and how to use it. And Nishant has a really cool demo to show off at the end. It's like show you some sample code. It's a really cool demo. Okay, so with that, why JSR 381 or visual recognition for Java? So we've all heard about machine learning, as I mentioned, and it's to me and to many people, it's extremely important to the world and to civilization. And I don't mean that to be flip about that, but we all know about some important discontinuities in our technological history. Like from this picture, we know that there's the invention of electricity, or the loom, or even computing, right? And if you notice the picture on the left-hand side, where we have a machine with two women, and just a little bit of history, the women were called computers back then, not the machine. So that was interesting. So now we have machine learning, and as Andrew Ng, one of the godfathers of machine learning, has called it like the new electricity. So it's as important as electricity. And it's interesting that both Zoran and I, we're both musicians, right? And in music, there's patterns. And maybe this is the reason why both Zoran and I were attracted to machine learning in the first place, that because our brain thinks like that, of patterns, that we were drawn to machine learning. And I'm saying machine learning in a real rough sense, but just for accuracy, I want to let everyone know that this terminology, because we're going to be talking about this terminology later on in the presentation. So the big item is artificial intelligence, right? And just think of the words. Artificial intelligence is where a machine is behaving like a human. It's expressing intelligent human behavior. Now, you might argue whether human behavior is intelligent, but let's assume that's intelligent. So it's a machine, it's emulating a human. So since we're all Java developers here, a subclass of AI, subclass of artificial intelligence is machine learning, where the machine is learning from data, right? So it's a subclass of AI where the machine is learning about data. Now, a subclass of machine learning is deep learning. So what we're focused on is deep learning. And deep learning it's machine learning, but it's a type of machine learning that uses what we have today, computing resources of today. We have powerful machines, we have cloud computing, we have advanced algorithms and advanced neural network algorithms. And we just went through the first phase of big data, and that's big data is getting even bigger. So we have all these resources at our disposal. So that's really formally called deep learning. But when you read about AI and ML and DL in the press, you might just hear of like machine learning as a generic term. But 9 times out of 10, you're going to be talking about, more formally speaking, deep learning, and that's what we're going to be talking about, is deep learning. But we'll call it machine learning. So for people out there that have not done machine learning, and let me say, well, I think I understand, I'm not quite sure. So let me give you a real quick definition, or make it understandable. So when you learn a foreign language, right, there's a couple of ways of learning a foreign language. You could learn all the rules, right? I know about the nouns and the pronouns and the verbs, and I know how to structure something, and I go to school to learn this. And in some foreign language schools, you actually learn the structures of things, and it takes you years to learn something. Right, so finally, after a few years, and then that you understand how to speak English, or how to speak Italian or French, or any other language. Now, on the right-hand side, there's a different type of learning a language. You could sit down with somebody and you could have a conversation, and as you converse with that person, you get corrected. Like, Frank is a Java developer. I need to buy him and so, well, what should I say? Buy him a car. Like, well, that's not quite correct. You should say buy him a coffee, or buy him a beer, right? So you get, over time, you get corrected, and you say what's correct, what's not, and that's effectively what machine learning is. And on the left-hand side, that's basically how we've been doing programming. We've been doing programming for like 50, 60 years. We've been doing programming like on the left. We've been telling the machine, here are the steps that I know to solve a problem, as opposed to the thing on the right. Right? So when you think about it, the way we solve problems in computing, and we've all done this, is that we think about the algorithm, and we think about how a human would solve the problem, and we code it up as if the human would do it, but we're just giving it to a machine because the machine certainly could do it faster and more accurate. But when we think about it, I mean, just really think about this. We're doing problem solving, and we're telling the machine to act like a human, just do it faster. So now we're in a different phase of computing. Now the machine is going to watch, and it's going to look at data, and now we have terabytes, zettabytes of data, and it's going to look at patterns, and it's going to tell us how to solve the problem. So it's a different type of computing. So that's the difference between traditional computing. It's a very, very high coarse-grained definition, but it's a difference between conventional, traditional computing and machine learning. So, and it's all about patterns. And we know from patterns, I mean, some of us that are more as senior developers have seen this book, Design Patterns, right, back from the mid-90s, where we saw things that were being used over and over again. And instead of reinventing the wheel, we would say, like, well, that's like a little composable unit, and we're going to give it a name, a design. a certain design pattern. And so this book it should be very familiar to many of us out there. But not everybody knows that that book and that concept was influenced 20 years before that by pattern language, which it was building engineers, not software engineers, but building engineers saw the same thing. They saw patterns in buildings. They said, why are we solving the same problem over and over again? We need to come up with components and have names for them. So pattern language is not just like unique to programming. It's buildings. And where did this come from? Patterns came from looking at the world. So when you look at the world is composed of patterns. So when I started thinking about this, 3 years ago when I was, starting to look for, okay, what's the next thing I should be learning? And I saw machine learning and I thought about patterns and I started thinking about like everything in the world is composed of patterns. Everything is. And here's machine learning that can understand patterns. So if you think about that for a second, that either should like light bulb over your head or send a shiver down your back. And this is, again, it's not new. So we have somebody, we have Norbert Wiener back in the 1940s, saying that the world is composed of patterns. So this is not something new. Like, looking at, patterns and having a machine understand patterns is not new. This is decades old, and it probably goes back centuries. So what is the core of machine learning? It's about noticing patterns, right? Recognizing patterns, and then you make predictions. So that's the core of machine learning. You see patterns and you make predictions. Now, what do you tell your manager at work? Right? You tell them something a little more, if you want to like get into a machine learning project, okay, well, you can say recognize patterns in the data. We have tons of data. We want to recognize patterns and we want to predict things, right? We want to, what's the most likely thing to happen, right? But for an enterprise, what's most important about this is that how do we take advantage of this, right? That's the key thing. So machine learning is not just for companies. Machine learning is not just recognizing patterns and predicting the future within a confidence interval, but it's also like, how do we take advantage of this, right? And what's really important, how do we take ethical advantage of this? So, if when you start getting more into machine learning, the concept of ethics is really, really important. And it's always important, as engineers, software engineers, we always have to think about ethical computing, but in machine learning, it's really, really important. So take ethical advantage. So several years ago, when I started learning about this, I said, okay, this sounds cool. This is a wave I want to ride. I want to learn more about it. So how do I do that? So I found out like, oh, I have to learn Python. You can start doing machine learning, but you have to have Python. And I said, well, I'm a Java developer. What do I do? And in fact, all my friends were Java developers, and there's 12 million, at least 12 million of us. And are you telling us that we all have to learn Python? Well, that's not going to work. I mean, nothing wrong with Python, but it's like you can't tell 12 million developers that learn Python just to do machine learning, right? Machine learning is it's a generic category, so I should be able to do Java. So Zoran and I, Zoran was, he's the author of the Neuro framework and the Deep Nets library. He's been doing this for a while, and I started like thinking about how do Java developers do that, and I'm coming from a web company back a few years ago. I didn't want another JavaScript, what I call a doomsday scenario. And this is not really a dig at JavaScript per se, but so we had this really cool invention called the web, but we only had one language to express our creativity. So this is like I invented music. And I said, here's a clarinet. I want you to come up with all the world's music with a clarinet. So yeah, I could do that, but it's not I'm a guitar player, or I'm a drummer, or I'm a piano player. I want to express my creativity that way. So to me, that's why I call it a doomsday scenario. Again, it's not a dig at JavaScript per se. Although if I had a few beers, I can go into that. But this is like having one language for something that's so vast. We can't let that happen again. And Python certainly is a good language. I mean, many data scientists, I mean, similar to Jitin, like I worked for an investment bank, and we had uh, what we called quants, right? The data scientists of the day, right? And we call them quants back then. They used S plus and R, and those were good languages, but not for the developers. They were good languages for the quants. And we took those algorithms that they developed in S plus and R, and we re-implemented them in C and C++ for production. So Python is a good language, right? It's a good language for data scientists, but we're not all data scientists, right? Actually a small percentage are data scientists. And we need something for Java. Now, there are some libraries out there for Java, but Zoran will go into what we feel that there are problems with those libraries. So 2 years ago, I ran a ML conference in Rome, where we were allowed to have face-to-face conferences. Rome's such a beautiful city. Unfortunately, won't be going back there anytime soon. And my keynote speaker, unfortunately, he was supposed to be the first speaker, but he was delayed. He ran a marathon, and he didn't he couldn't stand up after running the marathon, so he was a day late. um, and we had our speaker dinner the first evening, and so we had a good time, but he wasn't there, so he came the second day. I felt bad, so I took him to dinner the second day, and it was really interesting that I found out a lot about his background. He was a Java developer for 15 plus years, and he was doing ML, and we talked for about two and a half hours about what Java needed for machine learning. So there's a link on this slide to the article, this Medium article, on what Humphrey, Sheil, and I thought Java needed for machine learning. So it's a really good. It's only like a 6-minute read. So I suggest that you read that article. So we thought, and of course Zoran thought the same thing. We need to promote Java for machine learning, because we looked around. It's like, well, really, actually, no one is actually promoting it. There's some libraries here and there that don't feel like Java, right? And being a big proponent of Alan Kay, and one of the gods of computer science, he said, well, invent it yourself. If you don't see it, invent it yourself. And those are very, very wise words. So that's what we did. So Zoran and I went to all these companies, and we asked them, are you interested in a better Java API for machine learning? Without question, all these companies, from Twitter to Google to Amazon, and we talked to Brian Getz about this. Everyone was interested in having a set of Java APIs for machine learning. So this was quite exciting. So we started JSR381. So it's visual recognition for Java, and we started with visual recognition because we know that machine learning is more than visual recognition. Because, as you probably know, in business, you want to have a solvable problem. You want a deliverable, right? You can't have something you can't create in a finite amount of time. So we thought, like, well, visual recognition, we can come up with that pretty quickly. It took longer than we thought, but certainly quicker than boiling the ocean. And it's something that was visual, so people can see it. So we started doing that. So Zoran and I, and we were joined by Kevin Berenson from Open Value to help us. He was certainly quite critical to our development of JSR381. And we had a lot of contributors and advisors to JSR381, and from all different companies. So we were quite thankful that we had a lot of this input. And we've had some big companies interested in Amazon. Amazon has their deep Java library, and here's this article on InfoQ how they implemented our API. So Amazon actually implemented our API using their DJL. I don't have a link on this slide, but you can just go to InfoQ and search for that article. It's pretty cool. So with JSR381, and certainly Zoran will go into more detail on this, it's a Java-friendly API, right? And when we designed this, that was critical to us. But not only is it for visual recognition, but under the hood, it's a generic ML API. And I think I can start passing on to Zoran. He'll go into details of the architecture and the implementation. So Zoran, if you want to take it from here.
Yes, thank you. Can I share the screen? Can you allow me screen sharing, just?
Yeah, I think it's allowed. Yeah, we can see the screen.
Just Frank, you have to stop sharing screen in order.
Got it. Is it okay here?
Yes,
Okay.
I can start sharing it. Hi, everyone, and thank you for giving us this opportunity to present our work on JSR381. Well, I continue with one question that we already have in chat. How does this relate to existing Java machine learning libraries? Because, as probably many of you know, there are some libraries which are used more or less. But one thing we see as a problem is that there is not they don't share a common API. They don't have a standard. They don't have interoperability. It is very hard to use them with each other unless there are explicit bindings provided by some of them. So one of the problems is which library Java developers should start with. There are some which have been quite some time available, like Greco, but it is designed with all the Java API, like with Java 1.5. There are some like more advanced, like deep learning for J, provide deep learning algorithms, but again, it was designed at the time when some libraries were available and solutions, and Java has evolved a lot. And it is very hard to keep updated these libraries and or follow with the new developments in Java. And as I mentioned, all these libraries have different APIs. They support different algorithms, and sometimes it is very hard for average Java developer to get around to figure out what they should be using and for their problem and how they should be using, and if they need to change, is that the right decision? And some of them are very C flavored because they use native libraries, and they feel like something that would C developer would use. So one of the main design goals and principles when we were starting JSR381 is to enable Java developers to use machine learning just using their Java skills. So we are not assuming that the user of the standard API has extensive background in machine learning and image recognition, but providing a clear, straightforward API that average user could use to do some basic operations. So the main idea is to also make it easy to implement that API with existing machine learning libraries and imaging libraries, because one of the problems that we saw is that Java even don't have standard imaging libraries, because there are different platforms, different requirements, different types of imaging, different applications, and that space is really not standardized. And for example, even if you take Android, they have their own image class, like this bitmap, and you have AVT class buffered image, which is used a lot. And then there's something that's been available, this advanced Java imaging API, which was developed at some point for more complex images for medical and astronomy purposes. And there were libraries like ImageJ, which are not standard, but with lots of these effects, because Java actually have really strong support for image processing. But at the same time, it's not following with the latest developments on processing images on the GPU and deep learning. And that's also one field where it is behind the other solutions like OpenCV and TensorFlow and others. And one thing that we were hoping to achieve with this approach is to create a reusable design that could be applied for the machine learning applications in other domains too. Visual recognition is the type of application which is one of the main driving forces for machine learning and deep learning. And the latest innovations come specifically in that field. But if we are hoping to create, if we start, as Frank said, to start from this very narrow type of applications, but we're designing the API with other types of applications in mind too. So at this point, we started from very basic machine learning tasks. So what can you do with the visual recognition API at the moment? We supported basic machine learning tasks like classification and regression. And from visual recognition domain, we are going for image classification and object detection. So just to briefly explain, many of you are probably familiar. Classification is simply assigning input objects to some categories, to some predefined categories. Like if you want to separate images of penguins and rabbits, so you input one image and say this is a penguin and this is a rabbit. Or it doesn't have to be an image, it can be some other input data, some numeric data or some nominal data like enums, and then to just assign object to a category. For example, recognize if email is a spam or not, determine if financial transaction, credit card transaction is a fraudulent or not, and so on. The next type of task, a regression, is to estimate a numeric value of something, is to figure out the relationship between two values, like for example the marketing budget and the sales or the number of clicks. So on this image is very simple, this linear regression relationship, but with the neural networks which are supported API, even the more complex relations can be figured out. This is just a simple explanation. And what's interesting to say is that object detection is combination actually of these basic type of tasks that are being performed on the image data. So classification, object classification, you are saying this object belongs to this category, and with regression types of algorithms, you are figuring out where in the image specific object is located. There are many advanced details how this is performed in actual models, but the general idea is that. So you combine classification and regression algorithms on the input image data. So how did we achieve this interoperability and the possibility to combine different engines and apply it to different problems? So the main connecting point is this generic machine learning layer. So in this image, you see the architecture of the entire API. So this architecture allows us to plug different machine learning engines using a Java service provider mechanism. So we are defining a service provider interface, and we are required that each engine provides their service provider implementation, which is basically implementation of the interfaces from this generic machine learning layer. So this generic tasks like classification or regression, image classification, and object detection, they are defined in generic machine learning layer. You know? Actually only classification and regression. And this image classification and object detection are defined in visual recognition layer. You know, so specific application of generic machine learning tasks for a specific type of input, which is in this case are images, are created as an abstraction in this visual recognition layer. And so, since we have we wanted to support different types of images, since that's one of the limitations of the existing solutions, we provided this image abstraction component, which is basically a factory for different types of images. Now, what this block allows you is to use different types of machine learning algorithms with different types of images with the same standard API. So if at some point you figure out that you need to use different machine learning library or want to change, something new comes out, then if you are using this standard API, then you won't need to change anything, just to plug the different machine learning engine into this API, and everything will, your code will work without any change. So we are making sure to provide this clear and simple to use public API, which is very straightforward. You'll see how it looks like in the examples. And if you are a Java developer with a moderate experience, like familiar with using builders and interfaces, then it will be very straightforward for you to use it. So to get down to more details, to see how this actually works, so here are some of the main classes that implement what we talked about so far. So as you see, we have these three layers: generic machine learning layer, which is the main point, then visual recognition layer, which is specialization of these generic machine learning tasks for specific visual recognition task. And then we have implementation of these classes by specific machine learning engine. So one interesting thing to mention is that every machine learning engine out there have their own dataset class, you know, have basically their own dataset, their own collection of items that they want to use. So it would be very nice if all the engines out there would share the same dataset class. So once you get the data into that class, you can try it with different engines without need to, you know, restructure the data just to use the other class. So this data set is the main abstraction for like a collection of items for machine learning, and it allows you to specify these generic parameters, which are the elements of the data set. The next abstraction level is these different types of machine learning tasks. We have classifier, which is generic classification. Then we have binary classifier, which is specialized for yes-no classification, true-false classification. So classification with only two possible classes. And then multi-class classifier, where you can specify the result can be different classes. Now, in many machine learning libraries out there, the results come as a numeric, as integer, as a ordinal number of the class, which is practice, but it's not very intuitive, especially for the Java developer. So this API allows you to specify what are the types of inputs. This is the generic parameter, and what is the type of the result. And in that way, you can create a very custom, very specialized classifier for your own domain object. So you can classify workers, employees, visitors, transactions, whatever, and it will be very clear how it should be used, what it does, and what are the results it gives. So these are the task abstractions. And then in visual recognition layer, we have, if you want to classify images, we have image classifier, which extends classifier and can specify which types of images it is using as input. And in order to make it even easier to implement, we say, here's the skeleton for abstract image classifier, which implements image classifier and wraps specific type of machine learning models. So this generic parameter accepts the what type of underlying machine learning engine this is using. And then on the implementation level, we have image classifier network, which is using a buffered image as input and using convolutional neural network as a specific machine learning model. Now you'll see from the examples, one of the nice things from using this standard API, the end user does not need to be aware what's going on here. And even it won't have any imports from any dependencies from the actual machine learning library that provides implementation. So they are using only this machine learning standard API, and that's thanks to this service provider architecture. So this is the main idea. And how this looks like, maybe looks complicated, but I think it was good to show under the hood what is the main idea, and the idea is evolving. And this is the example how to do very basic image classification. This is traditional hello world for image classification, which is a classification of handwritten digit numbers. You know, there's a standard data set with 60,000 images, and it is very good to demonstrate the idea of this using machine learning to learn these different variations of the way some digits are written. So, you know, you won't find two same numbers, even if it is 3 or 4 or 5. Everyone is different, written different because it's handwritten, but it can learn to recognize it despite its differences. So here you can see how we are using image classifier interface. So we are classifying buffered images. So we expect inputs to get as the buffered image. And we do have this builder from neural net image classifier. So one of the things that we are trying to make in this API is to have a standard, straightforward naming convention. So if we have image classifier implementation, we said this is the image classifier, and what type of model is being used under the hood, we put also in the name. So neural net image classifier performs image classification using neural network. And also every model has a static builder method, which provides a builder to create that specific type of model and provides standard machine learning workflow. So basically you can instantiate, configure, and instantiate and train machine learning model just with this one builder sequence. So you specify type of input images, dimensions of the images, these data sources, network architecture, and so on, and just invoke build method. And you see from the initial examples how this works in practice. And when you want to use this classifier to classify images, you just invoke classify method, provide input parameter this image, and you get result as a map of labels and corresponding probabilities. So what is the probability that this input is some of these numbers? And if you want to do some type of classification with data, the approach is almost the same. So, but just we are using multi-class classifier. So this task, in this task, we don't want to classify to classify images, but we want to classify some data, which is generic multi-class classifier, not image classifier, and you specify type of inputs and outputs, and you invoke multi-class classifier network builder for that type of model, and to use it again, you just invoke classify method in this classifier. So also what's different in this API is using these generic parameters for specifying input and outputs and making it a standard API. So it is official standard. Every machine learning library out there have some type of classifier or some type of regressor, which are more or less suitable or intuitive. But I think it is very important to make it easy for developers, so that everybody starts using the same abstractions. And we are open to suggestions. This group is anybody can join this standardization group. So we are expecting from other machine learning libraries to take a look at this, give us some feedback, join expert group and contribute with their experience, and maybe provide support for this API in some of their next releases. So we are also open to make adaptations and in order to make this work for everyone. This abstract API is implemented using DeepNet's deep learning engine. It is a reference implementation, so which is like a proof of concept, showing that something like this can work. And the DeepNet's community edition is a pure Java deep learning library provided by the startup of the same name. And here you have a link with some examples, and you can look how it is implemented. So now I would give the stage to Nishan, who will show you how to do very basic image recognition, binary image recognition for cat and dogs.
Yeah. Zoran, I think Nishant got into a technical bump where his machine got hanged and he couldn't restart his machine because his model is there. So he's trying to recover from it. In the meanwhile, what we can do is we can take the Q&A from people. And I see that we have quite of a good Q&A going on on the chat window, but we can open up for people to, if anyone has questions, we can start with that at least. So in the meanwhile, if Nishant is able to join, it will be awesome. But if not, worst case, we will have another session just to do the demonstration of this.
Actually, I was answering a question about Amazon. I think maybe just to be clear, it was not AWS, it was Amazon. Their ML team implemented JSR381, and that article that I pointed out in InfoQ, it described how they implemented it. They used their DJL library to implement JSR381. So they have our API, but they use their engine to implement it. So it's actually a really cool article. And they have some nice examples of using our API in that article. So it's not AWS, but of course you can take that and put it on AWS and run it on AWS, right, or GCP or Azure.
Yeah. So thanks.
Thank you for thank you for so many questions. Yeah, it's very interesting. We will try to address as many as we can. So about will it make to core JDK? Probably not. We are not taking that path because it has a lot of requirements and it is very difficult, and we have to be compatible with everything. At this point, we don't have plans like that. We would like to support as many as possible existing libraries, machine learning libraries. So not getting into the core JDK, but supporting other libraries that are there and providing standard API.
Cool.
We are collaborating with the Java team and what's going on with JDK, and hoping to provide input to what needs to happen within JDK in order to make it more suitable for machine learning applications. But so far, the discussion we had so far, we don't see it as a part of JDK because it would make a lot of additional requirements and slow things, for us.
Exactly, and we also had spoken to Brian Getz, of course, who's the architect of the Java language, and he said that they have been thinking about some ML aspects to be added to the language, but they haven't really started. So if you can kind of like extrapolate, if they haven't really started, it'll probably take a number of years before any sort of language specific stuff happens. So that's why certainly the API is here now, and you can use it right away.
Cool.
Yeah. Another thing that I saw here is when we can expect for language processing. Well, it can happen even now because many language processing applications basically text classification. So we already have like a classifier API. So classification that accepts text. So now there we need to provide implementation for processing text, not images. So instead, this rectangular visual recognition, we need like a text classification or something like that. But yeah, we are designing this thing in order to be open to support other types of input and applications.
Okay. So I think Zoran, and Frank, one of the questions we have is, how are the performance of these APIs as compared to the counterparts in Python?
As compared to Python, did you say?
Yeah, yeah.
Well, it there in Java. So we are learning from Python, and we are trying to take good things from the Python libraries. But because of a different syntax, in Java, it is not possible to mimic everything. So there are these OpenJDK projects for Java syntax. Because one of the main things is Python have these named parameters, so you can specify a number of parameters in constructor and choose which one to specify. Java don't have that there, so that's the reason why we are using builders. And we'll see, we started some very early discussion about this support for named parameters, but yeah, we'll try to learn and take whatever it's proven to be good practice from Python to move that and use it in this Java version. But it's not possible to reuse everything.
Okay. Hope that answers Vikas's question. We get on to the next one where, how production ready is this reference implementation, and does it require GPU to run? And how's the accuracy of the model that is generated?
Well, the accuracy of the model, it really depends of the training, and the data provided. Depends how do you build the model. And depending ready for production, well, I think it is ready. This is not a final release. This is public review. There are some things that need to be done in addition. But from so far, I think it is solid to try to build the proof of concept. And actually, what phase that we are now is that we are hoping that people will try to do something with it and give us feedback, and then we'll make it production ready. The current implementation is based on a community edition of DeepNet, but there is also implementation based on this full version of DeepNet, which is much better. And we will have in future some kind of roadmap and continuously be releasing the new version of a community edition, which is improved performance and the new bug fixes. And one of the things that at the moment for this community edition, it might be slow it's not suitable for a large number of images and for big images, for real-time video processing and stuff like that. But for smaller number of images and a less complex problem, it can get the job done.
Cool. All right. So, Zoran, one of the questions which I have is, I have some experience on image processing in the healthcare space, and things that I've learned and still the research is going on is about the dimensions. So, doing deep learning in 2D images is maybe simpler than doing it in a 3D way. So I've seen few libraries which are available which do only 2D segmentation. The libraries who claim to do 3D segmentation, they're not truly 3D. They are 2.5D. Basically, they do 2D slices one at a time, and few which are coming up are completely 3D. So, in terms of dimensions, how does this is incorporated in this particular JSR381?
Well, at this stage, we support only 2D. We don't have support for 3D. As you said, you can take 3D image and process it as 2D. So even the segmentation and object detection API is not fully completed. What we have now working is this image classification, so object classification. So you can do scene recognition and stuff like that. And if you provide the cropped images, then you can perform object detection. But we don't have localization and classification in one model. So this is just a very basic, let's say, hello world of the visual recognition API to see if we got all these basic concepts right, and how people will use it, how they will react. And if this is good, then we'll move to more complex models. And even now one of the maybe main uh, uh, drawbacks at this moment is that we are missing a GPU support, and that's limiting the complexity of the models and the images that it can process. But we are working with the group from University of Manchester that are using with Tornado VM and providing implementation that can speed up the current DeepNet's implementation up to 10 times, and when we get there, it will be possible to do these more complex models and tasks.
Cool. Thanks. So one of the questions from Rodrigo Graciano is, JSR381 was submitted to review, and what happens after it gets accepted?
Well, we don't know exactly, but I guess there is some kind of official procedure, to provide the final implementation and maybe review, and it will officially become standard, and then we hope that other vendors will provide implementations because can join expert group. We are very lucky to have this that this is recognized as a good effort and initiative, and that Amazon has joined our expert group and provided implementation by their DJL, which is a really big thing. And also recently we have Grid Gain joined. Frank, did they join? Yes.
Yeah, so they're just about to join. They're going through some administrative issues with the JCP, but that should be resolved any day.
Yeah.
Okay.
So we expect then to get the implementation for different vendors, and it will make life easier for vendors, providers, and also for the developers, because there are so many cloud providers, so many engines, that when you get into ML, you just don't know what to use. And if you get this standard API, if they provide implementation of it, it will be great benefit. It will be easier for them to reach the developers, especially Java developers in Java ecosystem, because Java wouldn't be Java if there are no standard APIs. What we want to create is a collection API for machine learning, so something which does not solve all problems for everyone, but provides good solutions for the most users, and it is very easier and intuitive to use.
Cool. One of the
just while we're answering questions, I could share my screen with the URLs, with the download links, all that good stuff.
Yeah, so I think we have a couple more, and then what Nishant was suggesting is we can also do at the end, run by the slides that the demo slides that Nishant has, and then we can conclude on this. Okay. So, all right. So I think, yeah, these are the links. So yeah, we also have a recording of this, which will soon upload as soon as the session is done. So you will have access to these as well. So let's see. So one of the questions we have is from Praveen. Does it process stereo images?
The question is, does it process stereo images? What was the question?
Yeah,
that's the question. Does it process stereo images?
No, not at the moment. Only, I don't know, let us learn something. What is the format for stereo images?
So let me, even I'm not aware of stereo images. I don't know if they are regular.
Is there a Java class for stereo images? it is possible, you know, it would be possible. We have image class, abstract image classifier, and to specify, you can use existing model, which basically takes input as the tensors. You just need to provide some kind of implementation that image factory will convert this stereo image into a tensor, you know, and then you can
Okay.
feed it into existing model. It will not be a problem, but I'm just not aware if there is a Java class for stereo images.
Okay. Cool. Uh, yeah, we have question from Mala. Hi, Mala. Good to see you here. So our Mala's question is, Oracle has been promising usage of foreign APIs with Project Panama. Has that been useful to this JSR?
Yes, I think I answered that one below. In addition, while we're working on this, we also collaborating with the TensorFlow group, and we are working on the standardization effort for multidimensional arrays and the arrays together with TensorFlow and Deep Learning for J and some other guys that are in that group. And one of the ideas is to use this foreign API, you know, to provide this low-level integration that could communicate with GPUs through these foreign memory APIs.
Okay.
Thanks, Zoran. So if I could ask a follow-up question. So are we talking about the foreign API which have been made accessible in Java 15, 16, or are we talking about something else?
Yes, the foreign API 15, yes.
Okay, thank you.
Yeah.
All right. So I think we have Nishant. So Nishant, can you run by your slides of demonstration if you're not able to do the demo?
Yeah, I can do that.
Yeah.
Because of some issue, I had to restart my computer and I lost the basically UI application that was running on top of trained model. So I'll go through this screenshot. It is exactly I have captured all these steps, screenshot with all steps.
Cool.
So
No worries. Yeah. Thanks, Nishant. Yeah. Go ahead.
can Frank or Zoran share their PPTs?
So what to share slides?
Yes.
Okay, Frank is sharing.
Oops, that's not what I meant. Is that the slide that you want?
Okay. So yes. Thanks, Frank. Okay. So as Frank and Zoran explained, this is how you can use one of the API, right? A neural net image classifier. The use case or goal here is to we have a data set of cat and dog, and we want to recognize each image, right? So for that, we need to first train a model, right? So what we can do, this is the sample class called as neural network image classifier, and we will use a buffer image as an input class, and will provide the image width and height. Okay, so your data set will have a set of images, right? So we'll have to get the height and width of the image and pass here. Then comes up the concept of label file label file and training file, and I'll go into detail in the next slide. And then we will give the a network architecture file, which is nothing but the layers of the neural network, right? And this is the then we have a export model, right, which is nothing but your file wherein your model code model will be written, right? And then we have certain standard parameter like max error, max epoch, learning rate. So with this sample class and set of methods, right, you can train any image classifier, right? Frank, if you can go to next slide. Yeah, so there is a concept of label file and train file. If you see, it is the input to neural net image classifier class, right? So label file is nothing but a set of folder or classification number of objects that you want to classify, right? So you will group them into one of the folder and you will list all the folders, right? In my case, I have two folders. One is for class and one is for dog. So that goes in the label file, right? And then we have a corresponding training file, right? Training file is nothing but you will give a path of each image inside of inside a folder, right? So in our case, in label file, we have a two folder, cat and dog, and inside that we have a set of images, right, which we want to train, and the corresponding category. So we will have this training file created. Okay, you can have this gets we have a certain util method which can help you to get this training file created, right? And then you provide this as an input to neural net image classifier, right? And then Frank, if you can go to next slide. So once this label file and training file is created, we have some standard architecture file. So Zoran can go through it, but we don't get into the much detail as a Java developer, not a machine learning developer. So this is the standard file that is provided with the API, right? So yeah, Frank, if you can go to the next slide. Yeah, so once you run the neural network image classifier, it will start training the model, and if you see, it has two labels and 128 images, which the algorithm will try to train, right? And it will take over the iteration. If you see epoch 1, 2, 3, 4, etc., right? And it will show you the train error, train error change, and train accuracy, right? It will uh, go on increasing until it reaches the one, right? So after some time, once your model is trained, right, it will output that model file onto your file system, and then you can use that trained model to basically classify any input image, right? So once the model is trained, Frank, if you can go to the next slide, please. Yeah, so you can apply the model, right? So there is a, instead of export model, here you will use the import model, right? And you will give the path to exported model, right? And then you will say classifier, image classifier dot classify, and you will provide the path of the input image that you want to classify, right? And then it will return you hash map, and it will have a detail, right? What is the object and how much is the accuracy, right? So it will print that outcome once you call the classifier dot classifier, which is nothing but image classifier object, which you which we saw, right? And then once you classify, it will print the output. uh, Frank, if you can go to the next slide. Yeah, so this is the standard skeleton that we built. It is nothing but a UI layer which is built on top of that class, right? So it is nothing but it takes the image file, right? And it displays, and once you click on the is it cat or dog, it tries to classify and it prints the outcome, right? So what we can do, we will do is we click on the choose pet image, right? It popped up the file dialog, and then we selected one of the cat image, right, from the test set. Yeah, so you will see that image is painted. Now we will click on the is cat or dog. Yeah, so it will print whether it is a cat or dog, and whether it is successfully trying classifying or not. If it is not, then it will show it is not sure, right? Then similarly, we can choose another pet image. Now we will choose a dog file. So in this case, and then we will click is it a cat or dog, and in this case it will recognize as a dog, right? So yeah. that was a pretty quick demo, and there are certain more example that we have in our repository. So this was just one of the demonstration
Cool.
of our
Th-
API.
Thanks, Nishant. That was really cool. So one question which I have from the image processing we do is normally image processing, or using deep learning is very research oriented topic even for the applications. Now in that sense, for every use case we cannot use same type of segmentation algorithm. So do we have the facility to customize the or select the algorithms that we want to use on an image in this JSR?
Of course, yes, yes. I mean, if there is implementation of the JSR by some specific algorithm, so
Okay. Okay.
technically it is possible, but at the moment there are not so many implementations. We have DeepNets implementations, but we also have DJL implementation, which is a big thing because
Yeah. Yeah.
DJL provides implementation for PyTorch, for TensorFlow, and I think Cafe. So all these three can be
Yep.
used through DJL. So
Yep.
we are
Yep.
hoping to get contributions so that somebody will implement this API using TensorFlow, for example, and then we could do a lot of more. But the problem is that TensorFlow Java API is not fully implemented, experimental, and so on. People are working on that, but still not available yet.
Definitely. Cool. Sounds good. Thanks, Zoran. So I think we will have maybe 5 minutes or more, and we'll take final set of questions. So one of the questions coming from Raja Nagendra Kumar is, how many images were used in the demo and how much time it took to build the model?
Nishant, can you tell
Yeah.
us?
Okay, let me, yeah.
Yeah, so it depends. Like the number of images will determine your accuracy, right? So more of more the images that you will train, the better is the accuracy. In my case, I have started with the lowest bound, which is 64 by 64, right? So I have taken 180 by 180 PNG images, and this is the bare minimal training set that I have, right? You can choose as many as you can, which will give you a better accuracy.
So here, approximately how many were used, Nisha? How many images were used?
So I could classify almost more or less all of them successfully. But if you have certain images wherein you have a bad quality of the images, then in that case it might create a problem. But normally the training set or training data that we have, it's a standard data set that we get from the source, right? Standard source. So we get the good quality images. So it depends on the quality of image actually, which you are trying to classify.
Okay. And on your machine, any approximate time, ballpark time that it took to generate the model, just the training model?
Training model, like, yeah, it took around close to hour, right? So yeah, it depends on your certain tuning as well, right? Some of the standard parameter that we set, right, which will determine the accuracy. So yeah, and the number of iteration or epoch will have. So in my case, if I give 100 epochs, it will try to train your model with those many iteration, right? So in my case, I specify the 1,000 iteration, so it took more time to take the change on error to comes down to 1.0.
Mhm. Okay, cool. So I think we are almost there with our time. So I think I thank everyone for joining. We had amazing turnaround, and I also appreciate Mala and Vikas and other leaders from other India's other Java user groups to join. Thanks a lot for joining. And again, thank you, Frank, Zoran, and Nishant to get this session going. we will continue to get going this session with specific topics now, right? Since we now know what JSR381 is and what's coming, we will have more regular sessions going on forward. And this session is recorded, so I will upload that on the Mumbai Java User Group YouTube, and we'll share it on other social medias. So thanks a lot, everyone. Any final words from you, Frank, Zoran, Ishan?
No, just thank you very much for inviting us. And I just please, try the our API JSR381, and take the lead from Nishan and some build a little hello world just to get used to this, because this is a long-term trend and it's useful for your education and for your work.
Yep. Okay. Cool. Thanks. All right. See you all.
Thanks,
Take care.
everyone.
Have a
Bye.
good
Thank you,
weekend.
everyone.
Bye.
Bye.
Thank you guys.
Bye.